Hello and welcome back to Chapter 7. Now we're talking about the differences between implicit and explicit memory. So this is going to dovetail very nicely into the conversation that we were just talking about with the hippocampus. So people that have amnesia are generally going to retain memories for certain tasks. So things that don't require conscious thought, things like muscle memory. If you were to have severe amnesia, you would still be able to remember how to type. You would still be able to remember how to ride a bike. You would still be able to remember how to play video games. You still be able to remember how to play an instrument. But you might not be able to remember other things like what happened before your injury, or details about what year it is, or what somebody's name is, and things like that. And that's because we have two separate memory systems, the implicit memory and the explicit memory. Implicit memory is knowledge that we cannot consciously recall. Instead, we can show that we've remembered something. An example of this is the word stem completion task that we did at the very, very beginning of this chapter. That priming example is implicit memory. You're able to show that you've memorized something, but you might not be able to be consciously aware of how you remember that thing. Explicit memory is the opposite. With explicit memory, you can consciously recall what that information is. People that have severe amnesia are usually able to show evidence of learning and evidence of memory, but they can't always explain how they remember that stuff. My favorite example of this might be thinking back to H.M. Henry Molaison from the previous video. On the weekends, his nurses would take him out and would ride bikes with him. And before his surgery, he never learned how to ride a bike. And so he was always convinced that he did not know how to ride a bike. But the moment he would get on it, his body would basically take over. And with muscle memory, would be able to ride the bike no problem. Because on the weekends, they would come out and they would teach him, they would train him how to ride the bike. But because he had anterograde amnesia, he would never be able to really remember any of those other past times of going out and riding the bike. So the book talks about this really interesting example here where essentially there is a experiment that is being done where a fear response is being instilled in someone. And the way that this works is essentially that you have a blue light that comes on, and when the blue light comes on, a really loud siren happens. And so what they're looking at here is essentially how much someone tenses up whenever that happens. So here SCR is going to be, that is how tense someone is as a measurement of their skin response. And what they find is that people who are controls, so don't even look at any of these others, we're just going to focus on controls for now. People who don't have any seeming like problems or injuries in their brain show this level of tenseness whenever they are exposed to that blue light. They see that blue light, they're expecting the siren to occur, and so they start tensing up. So now we're going to be looking at how that compares with these two other individuals. We're going to have SM and WC. SM has damage in his amygdala, which essentially means that he doesn't have the ability to register fear. Doesn't have the ability to register that kind of emotional response that the amygdala typically handles. But his hippocampus is totally fine. WC is the opposite. WC has a perfectly intact amygdala, but does have damage in his hippocampus. So we can look at how these two individuals vary in their responses here. Alright, so you're doing this task, everybody's doing it the same way. They basically have this fear paradigm where they see a blue light, they get blasted with a siren a couple of times so that you learn the association that the blue light means that the siren is coming. And so for controls, they tense up. You can see that their tenseness ratings go up. And for WC, that goes up too. But here's the thing. WC, because he has damage in his hippocampus, can't tell you why that happened. He can't tell you why he got scared, but he can tell you that he got scared or that he tensed up. If you were to ask WC, why is that with explicit memory, he would be very, very bad at that. He would not be able to answer it at all. But if we look at the other person, the person who has damage in their amygdala, we see the exact opposite. They can tell us why they should be afraid, but their body doesn't really learn it. That essentially their body doesn't tense up whenever they see the blue light, even though they might be able to tell you, oh, the siren is coming. So this shows that there are two things that are happening here that are both important, that seem to be operating independently of one another. The amygdala is going to be helpful, and the hippocampus is going to be helpful. With the amygdala, that is going to help us learn a little bit about these implicit processes, about fear response, like classical conditioning. The hippocampus is going to be used more in the explicit side of things. All right, so I hope that makes sense. If it doesn't, the textbook goes into more detail about it, but you can always email me. If you want me to send you this article where this happened, I'm happy to do that too. So whenever we test people with amnesia, generally we're going to be using incidental learning tasks, which are ways that you're testing people. You're not telling them that you're going to be testing their memory, but that is ultimately what you're doing. Because remember, we're studying implicit memory. We have to find indirect ways of doing that. We can't just straight up ask someone what they remember, because we're assuming that if it's implicit memory, they can't say what it is they remember, but they can demonstrate it. All right, so in the example that I'm going to give you in this incidental learning task, people are asked to determine if words were real or if they were nonsense, and then they were going to do these word stems. And what happens is that patients that used words in the previous task, that they may not be aware that they remember those words, but they ended up using them to complete these word stems, even if they couldn't remember seeing those words to begin with. So let me give you an example of that. If I were to ask you to complete this word stem, so try to figure out what this word is. It might be easy, it might not be. People that have interrogated amnesia would look at this and they would say, I don't know how to answer this. I don't know what the word is supposed to be. And most controls are the same way too. Most control subjects are going to say that too. And now I'm going to ask you to do a separate task. So now I want you to remember what these 5 images are. So I want you to look at them, try to remember them. All right. I gave you a chance. And now I want you to tell me, what were the images that you saw? People that have interrogated amnesia are going to tell me that they don't know. People that are control subjects, like ourselves, are going to tell us that they saw a cat, a clown, a yoo-hoo, an elephant, a stop sign, and so on. They would get it all right. The people with interrogated amnesia would not be able to. Now, if I were to show everyone again this word stem, you will be able to get it, right? You know that the answer is elephant. Why? Because essentially you were primed earlier. You saw the elephant, and now that you see this word stem, then you know that the answer is elephant. But here's where things get amazing. If I were to do that exact same thing with someone with interrogated amnesia, they would be able to tell me that the answer is elephant, but they wouldn't know exactly how they know that. So they would get the correct answer, but they wouldn't understand where that answer came from. You would know that the reason why you know it's elephant is because you saw it in the previous slide. People with interrogated amnesia would not be able to make that kind of connection. So what does that mean? Basically it means that we have different independent memory systems. One that is explicit, that is handled by the hippocampus, and others that are more kind of bound to cortical areas throughout the brain. So explicit memory is going to be for things that you can vocalize, you can put into words. Implicit memory is going to be things like muscle memory, classical conditioning, priming, and things like that. All right. the final thing that I want to talk about for this video is another form of explicit memory. Again, this is not something that we're going to be talking about too much, obviously, in this chapter, because we're only going to be talking about it for one single slide. But when I teach this class memory, that capstone, this is something that we make an entire week out of. You can spend a lot of time talking about it. You can make this actually into its own course. But what episodic memory is the form of explicit memory. And this is the kind of memory that is most commonly interrupted with people that have amnesia. Essentially what it is memory for autobiographical events. So if I were to ask you, what did you have for breakfast? Where did you go to high school? Who was your first crush? What was the last movie that you watched? Things like that. Those are all things that you have to reflect about yourself, and you have to try to imagine what were you doing, where were you at, and things like that to answer that. And so another way to think about that is that Tulving, Indel Tulving, the very famous cognitive psychologist, said that ultimately what this does is it requires mental time travel. It requires you to be able to kind of go back in time mentally and imagine what you were doing, what you were eating, what you were, where you went to high school, who you were friends with in high school, and things like that. If I asked you, and so here's another distinction. If I were to ask you, who was the first president of the United States? You would be able to tell me George Washington. That is an explicit memory, right? But if I were to ask you, how do you know that? Where were you whenever you learned that information for the first time? Most of us are not going to be able to say that we remember where we were when we learned that George Washington was the first, right? We don't have that episodic memory intact. We do have the declarative memory intact. We do have that semantic memory intact. We do know the information, but we don't know where we got it. And Tulving, in case you're curious, last chapter we talked about levels of processing. This is the same Tulving from those examples. Tulving, along with others, argued that episodic memory is uniquely human, that it is something that only humans can do, and that other animals are not able to do. They're not able to reflect on previous events like that. But I'm curious to hear what you think. Here is an example of an extraordinary dog who had an incredible memory. And so if you're interested in this and pursuing this question, check out this video. You'll learn a little bit more about non-human memory by watching an adorable dog do a memory test. All right, so that's all that I want to talk about for this video. We're going to wrap up the next chapter by talking about how memory changes over different contexts. See you there.